Welcome to video lesson 9.3 on two-way tables. What we're going to do in this lesson is learn how to construct a two-way table and also, given a two-way table, to identify relationships that are between the categories in that table. All right, now a two-way table displays two categories of data collected from the same source. Each entry in the table is called a joint frequency. Okay, so we can see an example of a two-way table here. It's giving us the students and the grades, and the ones who studied, okay, and did not study, one set of data, okay, and also the ones that passed and failed, okay, and each entry, so we have 4 entries here, are called the joint frequencies. All right, so in example 1, we're using that same two-way table, and we're trying to see how many of the students in the survey studied for the test and passed. So how many actually studied and passed? So we just look in the follow the columns. Studied, okay, is in here, and passed is here, and where they connect is right there, 21 students. Okay. All right. Now, marginal frequencies. Okay. That is the sum of the rows and columns in a two-way table. All right. So what that means is, in example 2, we're going to find and interpret the marginal frequencies. So again, we're finding, and then we have to interpret, so explain what that means. All right. So we need to add up, so they're the sums of the rows and columns. So basically, we're adding another row, we're adding another column. Okay. And we will title that totals. Okay, total here and total here. And that will give us our marginal frequencies. So the total of this column is 22. The total here is 8. All right, now we need to find the total of the rows. So 21 plus 21 plus 2 is 23, and 1 plus 6 is 7. Now we'll do the sum here, and this total should add up, depending on if we go this way. 23 plus 7 is 30, and 22 plus 8 is 30. All right, very good. So what this tells us is that 22 students, okay, so this number we're interpreting now, that means 22 students studied. Okay, here 8 students didn't study. 8 students okay. This tells us the total number of students surveyed. So 30 students were surveyed. Okay. This number, this marginal frequency, tells us that 7 students failed. And here it tells us that 23 students passed. So that's the interpretation of the marginal frequencies. All right? Now in example 3, it says we randomly survey students between the ages of 12 and 17 about whether they should ride the bus to school. The results are shown in the tally sheets. We need to make a two-way table that includes the marginal frequencies. Right? So now we're given information, we have to actually create a two-way table for it. Okay, I'll move this out of the way slightly if I can. There we go. And what we have here, okay, we have bus, rides the bus, does not ride the bus, and their age groups. Okay, so what we're going to do up here is write age. Okay, and we have 12 to 13 category, 14 to 15 category, and a 16 to 17 category. Okay. Then we have the student here, okay, and whether they ride the bus, okay, or does not ride bus. right? And that's the start because that's the two different forms of information we have. Their ages, rides bus, does not ride bus. So how many students from 12 to 13 ride the bus? 5, 10, 15, 20, 24 it looks like. Okay. How many students 12 to 13 did not ride the bus? 5, 10, 15, 16. Okay. Now 14 to 15 ride bus, 5, 10, 12. Do not ride bus, 5, 10, 13. And 16 to 17 ride bus, 5, 10, looks like 14. And does not ride bus, 5, 10, 15, 20, 21. Okay. And now we need the totals. Okay, these are our marginal frequencies. Okay, so 24 plus 16 is 40. 12 plus 13 is 25. And 16 to 17 is 35. Okay, now rides the bus. We have 50. When we add these all up, 16 plus 13 plus 21 is another 50. Okay. 50 and 50 we know is 100. Okay. So hopefully 35, 40, and 25 is also 100, which it is. All right. So now, if we were to describe what these means, it doesn't ask us to do that here. It just says make the two-way table. That includes the marginal frequencies. But if we had to interpret the marginal frequencies, we would say that there are 40 students that are ages 12 to 13, 25, 14 to 15, and 35, 16 to 17 in this survey. Okay, 50 of them ride the bus. 50 of them do not ride the bus. There were a total of 100 students surveyed. Okay. Now, example 4 tells us to use the two-way table we had in example 3, and it's saying for each age group what percent of the students in the survey ride the bus to school and what percentage do not ride the bus to school. And we're going to put that in a two-way table. So again, we have our age group, okay, which was, I needed one more spot here, 12 to 13, 14 to 15, and 16 to 17. I guess I'm good. Sorry about that. And then we have our students and ride being bus to school and does not ride bus to school. Now, to figure out the percentages, we'll go back to our two-way table. Okay, and go back to our two-way table. We have, for riding the bus in the 12 to 13-year-olds, we had 24 out of 40. Okay, so if we do that in our calculator, 24 divided by 40 is going to be 0.6. How do we change a decimal to a percent again? Well, we move the decimal place 2 to the right. So 0.6 equals 60%. Okay, so riding the bus, okay, in the 12 to 13-year-old range is 60%. All right, and doesn't ride the bus would be 16 out of 40, okay, which comes out to a decimal of 0.4. Multiply it by 100 or move the decimal 2 to the right, and that's 40%. Okay. For 14 to 15-year-olds, riding the bus, okay, is 12 out of 25, and that equals 0.48. So it's 48%. Okay. Then 13 out of 25, be just a little bit more, okay, equals 0.52, which is 52%. Okay, and finally we have the 16 to 17 total. Riding the bus is 14 out of 35, okay, which equals 0.4, which again is 40%. Okay. And oops, went the wrong way, sorry. And lastly, 21 out of 35 do not ride the bus, which equals 0.6, and that is 60%. Okay, now we organize the percent of students in each category Okay? The ride the bus, do not ride a bus in a two-way table. But now we need to explain what one of the entries represents. Okay, so we can pick any one. I'm just going to pick this entry. Okay, and to explain what that means, okay, it means that since there were 14 out of 35, that equals 0.4, which equals 40%. Okay, so 40% of 16 to 17-year-olds students ride the bus to school. That's what that means to explain it. Okay? Now, part B here is asking us, does the table in part A show a relationship between age and whether the students ride the bus to school? Okay? So, what is happening here? The age range, if you ride the bus, it's 60%. A little older, it's only 48. A little older yet, it's only 40. Doesn't ride the bus, 12 to 13 is 40%. Doesn't ride the bus is growing now, 14 to 15, 52%, and even higher yet. So does this table show a relationship between age and whether students ride the bus? Yes. Okay. It shows that as you get older, you ride the bus less. Okay, so yes, the table shows as age increases, less students ride the bus. Okay, or less students are likely to ride the bus, you could say as well. All right, now we have a couple practice problems. Okay, there's two questions, but a couple parts to the first one. So you're randomly surveying students in a cafeteria about their plans for a football game and a school dance. It's showing you a two-way table, and it's asking you questions about them. So the first one just asks a general question about the table. The second one asks you to find the marginal frequencies and interpret them. So describe what they also mean once you get those numbers. Okay. Then in number 2, you're going to use this little chart here. I retyped it off to the side, so in case it was hard to read that, this is just retelling you what this table says. That's all. Okay, it was just hard to read that, then I copied from the book. So that's all that's telling you. Use that information to make a two-way table, including the marginal frequencies. Right? If you have questions, please make sure you write them down. I'll be happy to help you in class at the next day. Have a great day.